before actually using this ADC 0804 in an actual setup, let us revisit the functionality of each pin of ADC 0804. Let us start with data pins. We know that pin numbers 11 up to pin number 18, 8 data pins. They are data pins. This thing is clear. One thing I haven't mentioned earlier is pin number 18 will be LSB D0 and pin number 11 will be MSB D7. You also will be remembering that pin number 20 is used as VCC and we give 5 volts to it. That's also fine. Then we have V in positive and V in negative, pin numbers 6 and 7. We call them V in positive and V in negative. These are the differential analog inputs, where our V in will be equal to V in, the input voltage, input analog voltage that will be changed to digital signal will be equal to V in positive minus V in negative. Often V in negative pin is connected to ground. It's connected to the ground. That leaves us V in, the input voltage will always be equal to V in positive. That's the sensor output is connected to pin number 6, V in positive. That's also fine. And then we have 3 more pins. We have chip select, pin number 1. Pin number 1. This pin is active low, known as chip select. It's active low. That means to access the ADZ 0804, the pin must be always low. That is, the pin must be grounded. It actually enables the IC. We have then read and write. Pin number 2 is read. It's also active low. And write, it's also active low. These 2 pins are connected to the microcontroller like the data pins. And what's the function of these pins? First, before starting the conversion, we will be sending a high to low pulse on this right pin, a high to low pulse. And when we send a high to low pulse on this right pin, our ADC 0804 will start converting the signal into digital form. After converting it into the digital form, it will store it into an internal 8-bit register. And after that, it will send a low to high signal to microcontroller using the pin INTR, pin number 5. And after that, microcontroller will come to know that the conversion has finished and data is lying in the internal 8-bit register. It will send a high to low pulse on the read pin so that the data that is lying in the internal 8-bit register will be transferred to these data pins, pin number 11 to 18. Apart from this, we also have another pin number 9, that is known as A reference by 2. This pin actually fixes the reference voltage. If this pin is not connected, the reference voltage is fixed from 0 to 5 volts. And if we connect different voltage to this pin number 9, the reference voltage changes. For example, by connecting this pin number 9 to 2 volts, the reference voltage is 0 to 4 volts. And if this pin is connected to 1.5 volts, reference voltage changed to 3 volts, 0 to 3 volts. And changing the reference voltage actually decreases the step size. So that's A reference by 2. Then we have two grounds. We have analog ground and we have digital ground. They are respectively pin numbers 8 and pin number 10. Pin number 8 and pin number 10. We call them analog ground. We call them digital ground. Then we have two more pins used for clock, which actually determine the time, the conversion time of ADC. Clock R and clock in. They are externally connected with a resistor and a capacitor. Resistor between these two pins, a resistor R and a capacitor between clock in. Clock R is pin number 19 and clock in is pin number 4. And a capacitor like this. Capacitor C. The value of this capacitor and resistor actually determines the conversion time of ADC. Conversion time will be equal to 1.1 RC. And typical values of R will be approximately 10 kilo ohms, and typical values of capacitor are approximately 150 picofarad. Usually we take these two values, 10 kilo ohms and 150 picofarads. That gives us a conversion time of T equal to 110 microseconds. So when we will connect this ADC 0804 to microcontroller, what will be the steps of converting an analog signal to a digital signal? First, the connections. Data pins will be connected to these data pins will be connected to microcontroller. Read will be connected to microcontroller. Write will be connected to the microcontroller. INTR will be connected to the microcontroller. We have capacitor and resistor across 19 and 4. There will be A ground, data ground, and chip select will be grounded. Pin number 20 VCC will be given 5 volts. A reference by 2 pin number 9 is also usually given 5 volts or is not connected. That gives a reference voltage of 0 to 5 volts. And then we have pin number 7 will be usually grounded, and pin number 6 will be connected to the output of sensor. So that is it. So then what will be the steps in software? First, we will be sending a high to low pulse on WR pin, and whenever ADC 0804 detects a high to low pulse on WR, it will start converting the analog signal that is coming at pin number 6 into a digital signal, and will temporarily store it into an 8-bit register. When it finishes the conversion, it will send a low to high pulse to INTR through INTR to microcontroller. Microcontroller will come to know that the conversion has fixed and data is stored in 8-bit register, 8-bit internal register. It will send a high to low pulse to RD, and when the ADC 0804 detects a high to low pulse on read pin, it sends the data from internal 8-bit register to its data pins D0 to D7, which are connected to microcontroller, and then the microcontroller reads the data using one of its ports. That's it.